About 2 weeks ago, on August 10th, Russia launched a Soyuz rocket carrying a significant payload, the country's first lunar lander in nearly half a century since the Luna 24 mission in 1976. Sadly, recent reports reveal that the lunar lander crashed into the moon, marking a failure for the mission. Just a few days ago, an emergency situation emerged in lunar orbit shortly before the anticipated touchdown. The initial plan was for a launch on the 10th and a safe moon landing between the 21st and 23rd, a mere few days away. However, during an engine burn, a critical maneuver was hindered, leading to the problems that followed. Roscosmos, the Russian space agency, later confirmed the loss of contact with the lander in the growing belief that the lander was destroyed. Efforts are underway to ascertain the exact cause of the failure. This setback is particularly disheartening for the agency and the program, as it marked their first attempt to rejuvenate lunar exploration after decades. We'll delve deeper into the specifics of the flight profile, the mishaps, the sequence of events, and more. The Luna 25 mission embarked on its journey on the 10th, precisely at 7:10 p.m. Eastern Daylight Time, propelled by a Soyuz 2.1B rocket. The launch was initially successful, and the lunar lander was deployed as planned. The expected travel duration to reach the moon was about 5 days. On August 16th, the probe entered lunar orbit, a critical phase. It was during this phase that issues first emerged. A few days later, on the 19th, Roscosmos declared an abnormal situation after an unsuccessful engine burn command meant to position the lander in a pre-landing orbit. Regarding the specifics of the engine burn, Roscosmos explained, an emergency situation occurred on board the automatic station during the operation, preventing the maneuver from being executed within the intended parameters. During this period, the agency's primary focus was on re-establishing communication with the lander and understanding its status. It wasn't until earlier today that Roscosmos released a statement detailing the outcome. Translated into English, the statement read, "Around 14:57 Moscow time, communication with the Luna 25 spacecraft was severed. Despite the efforts made on August 19th and 20th to locate the device and establish contact, no fruitful results were obtained. Based on a preliminary analysis, due to deviations in the impulse's actual parameters from the calculated ones, the device shifted to an off-design orbit and eventually collided with the lunar surface. A dedicated commission will now delve into the circumstances surrounding the loss of the lander." Although the statement is skin on details, it confirms that the complications during the engine burn maneuver ultimately led to the lander's collision with the moon. The intended gentle approach and course alteration transformed into a completely divergent trajectory. The incident's intricacies are shrouded in specific key details. For instance, the mission had been delayed recently from early July to August, allowing for the final phase of ground tests and simulation to ensure a safe lunar landing. Furthermore, the lander was targeting the moon's south polar region, a region of interest not only for Russia but also for various space agencies worldwide. This is the very locale earmarked for future Artemis missions. However, this region is especially challenging for lunar landings due to its rugged topography with high mountains and deep craters. This requires intricate maneuvering for a successful touchdown, possibly explaining the complications faced by the Luna 25 mission. The equatorial region is relatively flatter, making it less demanding for landings. The quest for precision and complex maneuvers could be key factors in the outcome of the Luna 25 mission, a matter we hope to receive more insights on in the forthcoming months. The loss of this mission is a substantial blow to the Russian space program. Since the dissolution of the Soviet Union, Russia has not managed to send a successful lunar probe. This mission was envisioned to change that narrative. Importantly, the agency invested considerable effort in the design of the specific lunar lander. This journey began in the late 1990s with the evaluation of spacecraft designs in 1998. Throughout the 2000s, attempts to revive and complete the project persisted. The trajectory of the project faced interruptions, including a failed attempt at international collaboration with JAXA and the Indian Space Research Organization, ISRO. These hiccups did not deter Russia's determination, even with delays triggered by the failure of the Phobos grunt in 2011. It was at this juncture that the modern design for Luna 25 took shape. Progress faced hurdles owing to resource constraints on the spacecraft developer. In 2017, reports surfaced about the assembly of the propulsion system and support systems. The project was even pitched in a race against India's lunar lander to reach the Moon's south polar region. India's lander recently achieved a successful lunar orbit adjustment, positioning itself for a landing attempt at a similar latitude as Luna 25. Expectedly, the crash of Luna 25 adds uncertainty to the progress of the future lunar exploration endeavors. The timeline for missions such as Luna 26, 27, and 28, intended to lay the foundation for a lunar base in collaboration with China, is likely to experience further delays due to this setback. Roscosmos now faces a crucial decision: whether to relaunch Luna 25 after resolving the issues or proceed to more ambitious follow-up missions, potentially further prolonging the timeline. The lunar South Pole region holds immense allure due to its unique characteristics, including permanently shadowed areas that might house valuable resources like water ice. The region's mountain peaks receive ample sunlight, making them ideal for solar energy generation. Establishing an outpost here could unlock insights into the formation of the solar system and the availability of resources. Thanks for watching the video. Please subscribe to our channel Space Science Today and stay tuned for more space science videos.